Hello, this is Professor Brown-Sederberg, and I'd like to take some time to look at rounding numbers, which can be challenging in Java. So here you'll see that I've declared these variables, a double n with a value of 12.4599, and another double n rounded that has no value assigned to it yet, and then an int called n truncated. Now I want you to see the difference between truncating and rounding. When I truncate something, I just drop any decimal value. Now we can truncate a double in Java by casting that double into an int. And so here I cast the double n into an int and save that into the space of type int called n truncated. And so here with 12.4599, as I compile this and then run it, we'll see that it simply drops any value to the to the right of the decimal point. Well, let's make this 12.9999, which clearly we would think would be 13. We'll compile it and run it. We see that our truncating just drops any value to the right of the decimal point. So truncating drops any decimal values. What we want to do is round something. So what we could do is go to the Java API, and here we are in the Java API, and we go to the class math. We can see that the class math has a method round. It's actually overloaded. There's two versions to it, and here it is. Here's round and round. Now notice that this method round it must be past a double, this one a float. Both of those are floating point numbers. What we'll see though is that what it returns, this one, as I pass it a double, it returns back along a whole number. It returns back the closest long to the argument with ties rounded up. Here, this version of round that we pass a float to, it returns the closest int to the argument with ties rounding up. So both of these return back an int. Well, you might say, what about this method right here, rint? And what it asks for is a double, but it returns back the double that's closest in value to the argument equal to a mathematical integer. All of these return back whole numbers. They're of no use to us. If I were to look at them with my example of 12.459, here I'll call math.round and I'll pass it 12.4599, that's the value of n. So let's compile this, and then we'll run it, and we see that it passes back 12. Well, let's see if I pass it 12.9999. Let's recompile, and as I run, I get 13. That's the nearest int. Well, let's test this. What I'd like to do is let me pass it 12.50. Let's compile it, we'll run it, and it gives me 13. Okay, but notice if I were to pass it 12.49999, yep, we'll compile and run, and notice it still gives me 12. So it's not taking the least significant and carrying forward. That's important for us to note. Now, if I look at our int, and I'm going to pass it this 4.99, let's try that. We'll compile and run. So I pass 12.4999. I get 12 from both of them. Notice it's giving me back a whole number. Let me pass 12.9999. Both of them give me a whole number. Both 13. Let me pass 12.50 to both. And notice one gives me 13, the other 12. This is an example of understanding how methods work. Now, these methods, round and rint, don't work for us because they're not rounding a decimal. They're always giving me back a whole number. But I want you to see that when you use methods, you really have to understand what they do. And here, two that would seem to work the same way give me back very different values. Well, they don't do what I need done, so I guess I'm going to have to come up with something myself. Now here's a way to round a number. What I'm going to do, a decimal number, I'm going to round it, is I'm going to take the number n, I'm going to multiply by 100. That moves it over 2 decimal points. I'll then cast that number into an int, that is, drop any decimal values. So I've moved it over 2 positions by multiplying by 100, and I'm dropping here with this casting any decimal values. I'll then divide by 100, thereby moving it back 2 spaces, so 2 positions. So I now should have a number rounded to 2 decimal points. So we'll put into the space n rounded. And I did it in these steps just to let you see what's happening here. All right. So let's go back up to n, and we'll make it 12.459. All right. And here we're going to multiply it by 100, cast it, divide. So let's compile, and let's run. And it gives me 12.45. All right, but you know, I'd really think that might go to 46, because that's, well, let me change this to 9, 4.9999, and let's compile this again. And it gives me 12.49. Well, if I were rounding that, I think that would probably go to 12.5. I wouldn't just drop that off. Well, the way to take care of that situation is to add one more step. So you'll see that what I'm doing to n here, in this second way to do it, to round something to 2 decimal points, is I'm going to add 0.005 to n. I'm then going to multiply by 100. I'm then going to cast it into an int, and I'm then going to divide by 100. But I'm going to divide. Now, you want you to note that what I'm dividing by here is 100.0 in both of these. Remember, as I cast this into an int, if this were an int, by definition, I'd get an int back. I've made this 100.0, forcing a double to be returned. So let's look at this, our second way of rounding, and I'm rounding to 2 decimal positions. If you want to round to 3, push this to 0.0005, this to 1,000, this to 1,000. So we move in and out by adding positions. So let's compile this and then run it. And we see that it has rounded 12.4999 to 12.5. Let's test it with another number that's even more specific. So we'll test it with 12.4599. We'll recompile and then run, and we'll see that this one rounds to 12.46, a much more accurate rounding. So if we're trying to round numbers, here's a methodology. Add 0.005, multiply the resulting number by 100, cast the resulting number into an int, divide the resulting number by 100.0. That will round to 2 places. Now remember, this returns back a value. If you want to save that value, you have to assign it to a space. Had I wanted to overwrite the value of n, I would have saved it into the space n. So here's a way to round to 2 numbers, to 2 decimal positions. You can adjust it to round to more or to less. Thank you.